friends, welcome back to Little Lab with the Museum of Life and Science. We are really excited to do a special little lab at home with you using the kits that we passed out the other day. The kits have different contents, which we're going to use to do our experiment today. So the name of our experiment today is called Get Festive, but it's spelled kind of weird. Instead of using an F, it uses a PH, because pH is also what you use to measure acidity. We're going to be talking about acids and bases today. We'll talk about what's in your kit and what's in just a second, but first I want to ask all of you, what's an acid and what's a base? Or do you know any examples of an acid or a base? Or what does it make you think of? Let me know in the chat so we can talk about it. What do you think? Caroline and I will be thinking about it too. What do we think about when it comes to an acid or a base? Any examples? I bet you have an example right now. I bet you have one in front of you. Do you have any examples of acids or bases in front of you, Caroline?
Absolutely. I have right here a acid, which would be some vinegar, like some wonderful people in the chat are saying.
That sounds like we have some vinegar. Yeah, what else?
Does anyone, I know that when I hear pH and acid, I often think of lemons. And I think of lemonade. People always say it's very acidic.
It's really good. We have another friend in the chat saying that acid is sort of like a poison, or or vinegar is another example of an acid. I always think of that too. Whenever I think of acid, I think of something with a big skull and crossbones on it, something that's dangerous. I think about like radioactive green slime bubbling and sort of like that, right?
Absolutely.
So that's what comes to mind for me, but let's talk about, before we get started, what is an acid and what is a base? So the whole world all around us is made up of chemicals, and those chemicals are made up of teeny, teeny, tiny pieces called molecules. And those molecules are always interacting with one another. They're always bumping into each other and interacting and changing one another. An acid or a base is just a certain way to describe a molecule or a certain kind of chemical. So we could use traits to describe myself and Caroline as well. We could say one of my traits is that I have glasses. One of Caroline's traits is that she has glasses. One of my traits right now is that I'm wearing a sweater. And
I'm wearing one as well.
You've got one, perfect. You have headphones. That's sort of a trait that you are exhibiting right now. So different kinds of molecules do different things with the pieces that make them up, right? An acid is something that when it interacts with certain chemicals, it gives them ions. So little teeny, 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 tiny pieces that it's made up of, it gives ions. And a base is something that accepts ions. So basically, when it comes to things that are teeny, teeny, tiny, that are bouncing around, they're exchanging, they're passing back and forth little pieces. Acids are ones that give. Bases are ones that accept. And those interactions can look like different kinds of reactions. And I think, Caroline, you might be able to get us started with something, with an acid-base reaction that we can observe right now.
Absolutely. Now that's really cool. And I hope our friends in the chat are excited and ready to get going. You have some pieces from your kit where you will have some seashells. I collected mine on the beach, but they are wonderful little shells that we're going to play around with. Peregrine has some as well. And hopefully everyone was able to get some baking soda and vinegar or lemonade, whatever you have kind of available, lemon juice. And we're going to have two little containers here. Now, does anyone know which one's the acid or the giver and which one's the base or the acceptor?
What do we think of vinegar and baking soda and water, which we could also call sodium bicarbonate?
Yes.
Which one's an acid and which one's the base? I'll ask you this one. Which one's the base? Vinegar or baking soda and water? What do you think? Any guesses? What do you think, my friends? I think you're right. I think that vinegar is the acid. So vinegar is an acid, the baking soda and water is a base, and we're going
Wonderful.
to examine a certain reaction that can tell us a little bit about why we know that or how we know that. I'm gonna go ahead and hand it to Caroline. I'm gonna go to experiment cam so that you all can see what I'm doing a little bit easier.
Absolutely. And hopefully you guys can see what I'm doing here as well. This is my sodium bicarbonate or baking soda and water right here. And this is my vinegar. Now our shells, which are this really cool material, calcium carbonate, we're going to go ahead and put them inside of the baking soda and inside of the vinegar and see what happens. So I'm going to drop mine in the baking soda first. And we'll see if there's anything. I don't know about you guys, but I don't see much happening in my baking soda.
I'm going to go ahead and take, I only had one seashell out, so I'm grabbing another one, because in each of your kits you should have had a few little seashells.
Yes, and you guys are welcome to follow along and join in. Hopefully you have the materials alongside of you. If you can't join in, you're welcome to join along later as you watch. But I'm also going to now drop my other seashell as well as Peregrine, going to do the same, into the vinegar, and then we can see what happens. Anyone seeing anything with theirs? Oh, mine's kind of hard to see.
I'm going to bring mine a little bit closer.
Sounds good.
What do we think? Any reactions? Are you seeing any reactions, Caroline?
I am seeing something. It's hard to show on screen, but there are lots of little bubbles on the surface of my shell in the vinegar. Lots of little bubbles.
Ooh, we have a great description in the chat. It looks like it's disintegrating.
A wonderful word.
You can kind of see this with mine a little bit here, that there are some bubbles rising off of it.
Definitely. Yep, you can absolutely see it with yours, Peregrine.
It's even kind of moving my shell around a little bit.
Yes, absolutely. We're creating a layer of bubbles. Now, does anyone have a word for this where the two are interacting? This is a reaction, yes.
Perfect.
Very cool.
So we have a really interesting reaction. What's going on is the molecules that make up, all the pieces that make up the vinegar are interacting with the pieces that make up the shell. And the acid is giving ions, and the base is receiving those ions. And what happens is there's a gas produced. This is kind of similar to a gas produced when you mix vinegar and baking soda. It's just not quite as dramatic. These bubbles are kind of little. But a friend of mine in chat referred to it disintegrating. And I actually, I put a shell in about an hour ago. And I'm gonna try to find a shell that it was light. It was kind of like, oh yeah, I set this one aside because it looked kind of like the shell I had in here.
So cool.
So the shell I had was about this size, about this color. And I'm gonna try and reach in to get my shell that's been sitting in the vinegar for a while, because I can see that it's definitely smaller. It's smaller and it's also lighter.
Wow. Oh, it has gotten smaller. It's almost like it's softened out, kind of rounded the edges off a bit.
It is. It used to be the same size as this one. I don't know if you can see that, but it is a little bit, it's got kind of this stripe where the coating of it is almost like flaking off, and it's definitely smaller. It's shorter than the other one. I'm going to keep it in that vinegar to see what happens, and I would recommend that all of you do the same. Does it keep bubbling? Does it stop bubbling at some point? Does it disappear completely? That's always an interesting one. So I would recommend your little cup with vinegar and your shell in it that's bubbling. Set that aside and come back to it in a little while to see if anything has changed. I'm going to put mine over there.
That's a great idea. I will do the same. Mine are definitely bubbling up more as time goes on.
That's great, Caroline. I love that you were able to find shells from the beach. That's so cool. Because those are like bigger chunks, so you can kind of see where the bubbles are coming from. We have a great observation in the chat, a friend saying that the bubbles are at the bottom. I see that too. I see that those bubbles are
Same here.
Yeah, like kind of clinging to the shell. And when I look into my sodium bicarbonate or my baking soda in water, I don't really see any bubbles. I see little pieces of baking soda floating, but I do not see any bubbles rising off of it, right?
Yeah, I see no bubbles whatsoever.
So there's no reaction here. They're not exchanging ions. Let's go ahead and let's look at some other acid and base reactions. One reaction that we can sort of see, that we can track, is, I'm going to borrow a little bit of my vinegar here, that we can track is by using a certain tool called a pH strip. And all of you should have some pH strips in your kit, wrapped in some tin foil. I know Caroline has some. You've also got a nice laminated piece of paper that has some different colors and numbers on it. And then there's one last piece of paper that has some nice little lights on it. Go ahead and take all of those out if you haven't already. These pH strips can measure how acidic or basic something is. So it's sort of like a thermometer, but for acidity. So if we take one of our strips and we put it into one of the chemicals that we have, there will be a reaction. And I'm going to let you all see what happens. I'd like you to take a pH strip and then grab your vinegar, and it's okay if it still has your shell in it, but go ahead and take your vinegar and you can dip it in, kind of like you're dipping a cookie into milk, just a little bit. We don't want to drop it in there, but we're just going to take a quick dip. Now you have a pipette that you can use as well if you want to grab a drop of it and drop a little bit onto it. But the thing about using the pipette is you'll have to rinse it out in water after. So I think for this first reaction, I'm just going to dip it in. So go ahead and then tell me what you notice. What do you see, friends? I noticed a pretty strong reaction. What color did it start out? Yes, it turned orange. It turned almost red. What we can do is we can take our scale and we can try to match which color it's closest to. Now I think mine is closest to maybe a 3 or a 4. What about you, Caroline?
I think mine is also closest to probably a 3 or a 4.
That's great. That tells us, so that low number and that orangey reddish color tells us that it's a strong acid. Ooh, we have another friend who said that theirs turned orange as well. So this one is an acid. That was the vinegar that we tested. Let's test something else. I think I'm going to test some of this baking soda and water.
I will also go ahead and do that.
Let's see what you find. I'll let you go first, Caroline.
Okie doke. Dipping it in there.
Whoa.
Wow. Oh yes, someone in the chat said theirs is green. Mine is also green.
I dropped my strip onto my other strip, which made it change color, so that was very interesting.
Oh.
Yeah, I agree. Mine is definitely pretty green. It might be something between maybe an 8 or a 9. How about yours?
Yeah, I would say mine's probably a 9.
That looks pretty good. It's sort of slightly bluish.
Mm-hmm. The slightest bit blue.
So I'm going to try another chemical that I have, and I think you have some as well, Caroline. I'm going to try testing some water.
Very cool.
Do you have any guesses? What do you think, friends? If I dip this into water, do you think I'll find out that it's an acid or a base or something else? What do you think? I have a piece of glitter stuck to my hand. I'm trying to get it off. There we go. We're not sure.
Does anyone have a guess as to what color? Ooh, in the middle.
So we think maybe it'll be in the middle between green and reddish orange. Let's test it out. Let's find out. So if you have any water or anything like that, go ahead and try it. I'm going to dip mine in.
I will also grab some water off screen.
What do you think? You know, when I first dipped it, I thought it just kind of looked wet. It didn't look very different. But
Definitely.
I think that mine, and yours too, Caroline, looks a little bit green.
The tiniest bit. Maybe a 7?
I was thinking it's almost a 7. Mine's really probably closer to a 6.
Mm-hmm.
And water, we say, is something that's neutral. We say it's neither an acid or a base, so it should be right in the middle. It should be right at 7. But because of something called the carbon cycle, water that's not in a vacuum, that's just been sitting out, right, will tend to be slightly more acidic. So that's pretty normal, but it probably depends on how recently you got your water. I know that when I tested mine earlier, it was a lot greener, so it's gotten slightly more acidic as it's been sitting out.
Very crazy.
And yours is and I see that yours as well is very green.
Yes, and I just poured mine, so it was poured maybe 10 minutes ago, perhaps 20.
So I'm going to keep testing a few more chemicals, and I hope that if you have some more chemicals at home, you'll test with me. But I wanted to quickly mention what we're going to be doing with our little kind of holiday lights here. And I was thinking we could use some of these different strips to show, to kind of be like our little light filaments. So it's sort of like we're decorating our lights to make them different colors, just like some holiday lights actually look.
So cool. I will go ahead and do that with mine as well here.
So here's some different ones.
Here's what I have so far as well. Oh, one just fell off.
And if you do want to hang it up at some point, it's really great to put tape over it, and that'll help keep it where you want it to be. I want to test a few more, Caroline. I want to test some lemon juice.
Ooh, very exciting. I will go ahead and test some lemon cleaner, perhaps.
Ooh. So what do you think, friends? Do you think that lemon juice and lemon cleaner, will they be acids? Will they be bases? What do you think? Will they be different? Will they be the same? I think let's test it out. I'm going to test lemon juice. And then Caroline, you have a lemon cleaner.
Yes, and it's very colorfully yellow.
So that's something that's a household chemical used to clean off surfaces. So it's not really from a lemon, but it's lemon scented. Oh, this is really great. In the chat, we have someone who tried soap and it turned out as around an 8. That's great. So it was a greenish color. I love that.
Very cool.
Let's test ours, Caroline. I'm going to test my lemon juice.
All right.
Whoa.
Wow. They turned out very different.
I love this. This looks close to maybe a 3 when I did the lemon juice. But look at Caroline's. The lemon cleaner. What would you say? What number do you think it resembles?
Ooh, I'd say that one's almost a 10.
Wow.
It's between maybe 9 and 10 there.
So if it's a higher number and it is kind of this more bluish purplish color, we say it's more basic. So a lot of different cleaning chemicals are more basic. I also had some lemon cleaner. I also have some window cleaner here that I was going to test out.
Ooh.
Some regular window cleaner. Oh, we have someone who tried pickle juice. They said it was about a number 4. I love that you tried that.
That's so cool.
Whoa, here is my window cleaner.
Wow.
A really dark color. It's a really dark, maybe about a 10 or an 11.
Mm-hmm. Oh, that's amazing.
That's really fun. I've got a lot of different colors here. I want to see if I can try I'm going to try 2 at one time here, just because we're almost at the end of our experiment. I have 2 household chemicals here that I wanted to see if we could try out. And I wondered if you had a guess. I have some hydrogen peroxide, and I have some alcohol, some isopropyl or rubbing alcohol. And I wondered if you had any thoughts about if one will be an acid or one will be a base.
Any guesses?
What do you think? Because when I think of isopropyl alcohol, I do think of a very strong chemical. So it makes me think, oh, is it going to be an acid? Similarly with hydrogen peroxide, it bubbles. So I wonder if that means it's an acid. But what I'm going to do is I'm going to test it out and see. And if you have a hypothesis, you can put it in the chat. I'm going to go ahead and dip it into the hydrogen peroxide. Oops, I'm actually going to drop it in the hydrogen peroxide.
Perfect.
But you can see that I'm not seeing a whole lot of color change.
Oh. Not much change at all. That's shocking.
So that means that it's pretty neutral. It might be something near maybe a 6 or so, but it's pretty neutral. So even though it's a very bubbly chemical, it's very neutral. Let me try one last one, this isopropyl alcohol.
Exciting.
And I think this one ended up being pretty neutral as well, very slightly acidic. Oh, we have someone who tried hand sanitizer. So it has the same chemical, has that isopropyl alcohol in it, which is really pretty neutral. Even though it's a really strong chemical, it can help eat away at the coating of different kinds of bacteria and stuff like that. It isn't an acid. So not all acids eat away at things. And not all things that eat away at other stuff are acids, right?
Yes, very true.
I'm gonna go ahead back to my face cam here. Do you have maybe one last one you want to try, Caroline?
Yes, so I just dipped, and it's actually getting everywhere, in this lovely orange cleaner that is actually a pet stain remover. And we got a super dark bluish green again. Actually, it's even darker than the lemon cleaner. If you look in comparison. I don't know if I can pull up the lemon cleaner, but they're about the same actually.
That is so interesting. One of them does look a little more blue, and something that we'll also notice is that the colors will change a little bit over time. They'll get kind of closer back to neutral unless you seal up the strip with tape. So if I just left these out in the air, then they would start to turn back eventually they would turn back into the normal color of the strip, just because that's how the carbon cycle works. But they kind of look like some nice pretty lights, and if I wanted to keep this as kind of a craft just to have, I could tape them down. Oh, we have someone who tested saliva. That's so interesting. I went to the dentist the other day and they tested my saliva with a pH strip. I thought that was so interesting. And mine turned green as well when it was nice and clean. It turned really nice and green. So that's nice. It means that it's probably around a 7, right? Which would be great if our saliva was just about neutral.
So cool.
I love it. Caroline, yours looks so lovely. I bet that we have a bunch of beautiful colors out there as well. I hope that you all can continue testing because I gave you, it should be around 20 strips. So we definitely didn't test 20 things today, but I would say take your strips and test different things. See if salt water has a different acidity than fresh water. Try different kinds of soaps, different kinds of chemicals that your adults can help you use, because we always want to be careful when we're handling household chemicals. But there's all kinds of things out there, and they all have these different pHs, these different levels of acidity and basicness. Thank you so much, friends, for joining us. I really, really enjoyed being able to do this experiment with you, and I loved being able to hand out these kits and see some of your faces. Next week, Lab at Home will be back, and we're going to be learning about glaciers and glacial drift. And that's going to be a fun one. I'm excited about it. And then the week afterward, we will have another little lab at home where we will be exploring weather. So I look forward to hopefully seeing all of you again and doing some more science with you.